Hello to everyone, and welcome to this new DevSu Lab. Today's topic, Digital Identification Overview. My name is Sebastian Abdo, and I am Training Manager at DevSu. DevSu has over a decade of experience delivering a range of custom development services for startups, small medium businesses, and enterprises worldwide. This is thanks to the fact that we have experienced and talented engineers in developing intelligent applications, integrated services, and scalable systems using state-of-the-art technology. So let's get into today's topic. While digital identification has become essential for new online world, the reality is that it has been part of our society longer than what you would have expected. This lab will provide an overview over common concepts, the history of the application on civil and criminal biometrics in the real world. Digital identification has many applications, such as member and affiliates identification for banking and insurance, digital signature in legal documents, border control system for national migration departments, and so many others. But of course, I don't want to get ahead of the content of this webinar, right? So before we start, I want to just make a couple of points here. We've enabled the Q&A chat feature for those following us on Zoom, and the chat and comment for those on YouTube. So if you have any questions, address them so we can get them answered. Also, if you miss anything, don't worry. We'll be sending the link of the video when it's available. Today's lab is going to be presented by Danny Aguilera, who is part of DevSu's engineering team. He resides in the capital city of Tegucigalpa, Honduras. His work in biometrics started around 2013 in a casual implementation of facial recognition for the Honduras national election and formalized in 2019 while working with Grupo Visión. Some of the projects related to biometrics are the National Migration System for Border Control in Honduras, Police and Forensic Department for El Salvador, and National Identification System for Jamaica, among others, of course. So, without further ado, it's my pleasure to present Danny Aguilera and his lab Digital Identification Overview. Danny, it's all yours, please.
Thanks, Sebastian. So, well, I mean, there's nothing more to say than when Sebastian just said right now. I'm a .NET developer. I think that after almost more than 12 years, actually, of being a developer, I would consider myself as a senior. This DevSu lab, as he said and mentioned, is digital identification. But this is more like an overview in the sense that there's so much about this topic, guys, that it's not going to take us just 1 hour to try to cover most of the topics here, right? So what we're gonna do, it was that we're just gonna take small things of a lot of things and just kind of discuss it a little bit. So if you ever want to make questions or you want to raise your hand and maybe try to discuss a little bit more of something because you feel that it is important to you to know about this, please go ahead and do it. Don't worry about it. I'm just trying to make this a little bit more as a discussion and try to address a lot of the questions. Before I get into the specifics on the applications and everything, I really want to make a quick quick recap of what is identification, how this is started, because digital identification is just the digital representation of what we already do. remember that most of what we do in technology is already represented in real life. So in that sense, I want to discuss, since when are we doing this, right? Since when are we identifying people as unique people, as a unique person, right? What's the deal with that, right? And then we're gonna talk a lot about some big words, because in this digital identification world, there's a lot of word and a lot of things that you might get confused. So before we get to the code, before we get to some applications, we're going to talk about some of the words, and we're going to get them cleared out. And this is important. Like, if you have questions there, please do make them, because this is really important for us. Once you get to the code, you get these ideas straight up. Okay, so let's go to the first part, and let's go for since when, right? Since when is the humankind being trying to identify one person as a unique person, right? At some point in history, this was around 1700s, Johann Christoph Andreas said that although the arrangement of skin ridges is never duplicated in two persons, nevertheless, the similarities are closer among some individuals. In others, the differences are marked, yet in spite of their peculiarities of arrangement, all have a certain likeness. So this is very important, what he was saying. He was a doctor, he was a physician, and he was, a scholar. So he wrote a lot of papers, and one of his works around fingerprints, he was saying that he notices a lot of differences, but at the same time, a lot of similarities. And this is important because in the code that we're going to see eventually, you're never going to see that nobody is 0% alike somebody else, right? Like, at some point, you are alike in some degree. It's never 0, and it's never 100, which is curious, right? Even your fingerprint compared against your fingerprint is never going to be 100% alike. And your fingerprint against another one is not going to be 0% alike. There's always kind of like a floor there, and it's a floor up and a floor down. So this is very important. Just try to remember that. But this actually applications, right? Like, since when we are actually started doing this, it's very curious, because we started doing this since 1901. Look at this, guys. We've been more than 101 years, 121 years working with biometrics. Since the word biometrics, it's exactly the biological metric that you are measured with, right? So since 1901 in the UK, the police department there started to gathering and trying to figure out, okay, since this guy told us that most of the fingerprints are different but alike, there might be a way so that we can solve the murders. And so they started collecting fingerprints. At the same moment, 1 year later, the New York Police Department started doing the same thing. So throughout 20 years, they started doing this, and the FBI at some point said, you know what, let's do something. Like, for the entirety of the United States, let's gather all the fingerprints that all the police departments have been doing, because since New York did it, a lot of other departments started doing it. So they said, okay, let's collect everything, right? And let's have a standard for this. Let's collect all the fingerprints, but at the same time, let's do it in an organized manner. So then we can start doing a lot of processes for identifying people. So they started, centralizing this repository. Don't worry, repository is not anything technological. It's just the plain it's the plain definition of the word, which is a collection of stuff. So they had their repository created in 1920s, and they had around, I think, 10 million records at some point. So it was pretty big, right? So just remember having all those cards that you can see there. These cards that you can see here, these. Just imagine 10 million of those. So yeah, that's a lot, right? So a problem started to rise. A problem started to rise in the sense that if you were adding 400,000 file cards a month to its archives, and you're already receiving 110,000 requests just to check somebody's name and fingerprints, just to see if that person is who is claiming to be, then you got a problem, right? So by 1944, you had 23 million cards of biometrics stored in what you can see, those little boxes. So you have like a little box and you just like opened it up and started like getting one card and just looking for the name and just starting to compare the fingerprints that they gave you from that guy. And you can say, you know what? He's not the guy. Like he claims to be Danny Aguilera, but no, he's Sebastian, right? So this is what was happening there. So this is beautiful in the sense that you can see that technology actually really solves real life problems. And this one was one of them. There was this necessity of having a way to organize this stuff and to make these comparisons a little bit faster. So in 1984, the San Francisco Police Department and the there was a technological partner here. I'm not going to mention them right now. I'm going to mention them later. But let's say that in 1984, the San Francisco Police Department created what they call AFIS. You're going to hear this word a lot, AFIS, which is the acronym for Automated Fingerprint Identification System. So they created this AFIS, and there was a big game changer of this, because now you can not only compare one fingerprint of a person to the same fingerprint of that person just to verify if that person is who he is claimed to be, but also you can compare now this fingerprint of one person against all the fingerprints that you have. Now, this was a game changer because now you're just not comparing or saying Danny is saying who he is, but only saying Danny is not who he is, but also he's this other person, right? This was a game changer. And this actually created a phenomenon. By 1999, 500 AFISes were deployed around the world. Like, this is a big number. 1999, remember guys, that technology wasn't that strong there. And for example, the internet was just, a little baby, and computers, I mean, the way that you connect and send data over the networks was very complicated, was very complex. So having 500 AFISes around the world is kind of like a big deal. And this way you can tell how big the problem was and how big the solution was. It was bigger than the problem. Now, quick question here. I don't want to be talking all the time. So, and I want to have, some people try to interact with this presentation. Do you know, guys, what happened in October 6th of 2000? This is like, everybody knows this. Like, not everybody knows this, but most of us noticed that something happened in October 6th of 2000. Do any guys have an idea? If you want to leave an answer to the chat there, you can do it quickly. Nobody? Actually, I just left a hint on the presentation. As you can see in the presentation, you have a CSI fingerprint analysis screen. Do you guys know what that means? On October 6th, believe it or not, on October 6th, the first episode of CSI was aired. And CSI, as you know, and they have this as part of their software, they were using this Aphesis UIs as part of their, appeal, trying to sell this to the viewers. Like they said, oh, let's grab this photo and zoom in, clarify, zoom in. Oh, there's a fingerprint. Scan it and let's find it on the database. Well, whenever those guys were saying that, and whenever in every police show that you guys love to watch, whenever they say, let's scan those fingerprints and let's check them on the database, well, that database is an AFIS. So that's a really, really awesome thing to know, that just there's a whole set of shows of crime that rely their appeal on AFISs. So that's an interesting thing to know, right? Okay, so let's move on, because I don't want to take too much time here, and let's start cleaning up some words, right? I know there might not be a lot of questions regarding history. This is something that happens a lot into very close groups of what you call businesses. Actually, most of our clients can be government. This is not going to be in too much of a private sector, only if you got a lot of money. So maybe banks, maybe social, maybe banks, maybe big companies that can afford this amount of investment, because it is expensive, right? So let's get something out of the way. Do you guys remember that when I talk about the FBI in 1920, trying to create a standard of how to save stuff? Well, they created this organization, which is the National Institute of Standards and Technology, and the National NIST, Institute of Standards and Technology, says about fingerprints, or by digital identity, they say that is the unique representation of a subject engaged in an online transaction. Now, this wording seems like very simple, but actually carries a lot of meaning, because it says that it is a unique representation. If you would say unique in the digital context, this bears a lot of context. What do you mean by unique? Remember that we can just grab a fingerprint and copy it, right? And we can just grab a file, a set of database, just copy it and send it over. But this unique representation is actually it's a wording that we're taking what we gather from real life, which is from your fingerprints, and we are making a representation. We are not replacing your identity. We're just representing your identity by your fingerprints, your face, your iris. There's a lot of ways we can do this. And we're just making a representation of your identity. And we're making it unique. And we are making a guarantee that there's never going to be a representation of your fingerprints on the same system. This part of the same system, very important, because there's a lot of people having your identity. So in the same system is the guarantee. Now, in other systems, we don't know, but on the same one, we do. And it says that the second part says that it's going to be engaged in an online transactions. So basically what we're doing is we're going to use this unique representation of your identity and use it to guarantee, or to, just use as a signature in whatever online transaction you can do. So there's a lot of ways we can do this. Sebastian mentioned one, which is digital signature. If you guys don't know about digital signatures yet, there's a big digital identity is a big part of it, because this is the only way that we can guarantee that the person that is signing is the person that created the signature, and it is the same person that keep using that signature and placing the signature on PDFs or Words. There's a lot of ways to do this, right? So yeah, this is big. Now, Another thing that I want to clarify for the word jumble is that you guys are asking yourselves, okay, but what do you mean that this is already been working on since 1940s and since the 1980s, that we have AFISes, 500 AFISes deployed since the 1999, but I don't really get it, like I don't see it. I'm just going to throw some numbers at you so that you guys can really picture what's going on, right? So there's 1 billion people estimated to lack a legally recognized identity, right? These are places where there's no identity collected at all. People that most of the interior of the countries, maybe, rural sections of your country, or places in the world where, technology hasn't gotten there yet. So there's 1 billion people estimated that they don't have a legally recognized identity. So this is a big issue. So this is 1 billion people that right now require from our services. So these are potential customers. So that's a way you can see that. And then you get 3.4 billion people that have some form of ID, but there's no digital trail. What this form of ID but no digital trail, what you mean? Well, this means that if you ever have an ID card and at some point you got your fingerprints, maybe, I don't know, just like with ink, and then placed on a piece of paper, well, this is a form of ID. If you got an ID card and you left your fingerprints when you got that ID card, well, that's a form of ID. But it's just not digital, right? So this is the thing that they were doing in 1940s. This is the thing that we're doing in 1901. There was just collecting fingerprints and assigning one person to it, but there's no digital representation yet of that identity. So again, there's 3.4 billion people that can be our potential customers to have this represented in the digital world. And then we have 3.2 billion people that have some form of ID in a digital trail. This means that your country, perhaps when you got your ID card or your licensed driver, your driver's license, sorry, instead of having your fingerprints scanned with ink and placed on the paper, you have them scanned with an actual machine. Some customs, for example, some customs personnel in some countries, when you get in or you get out, they ask you for your fingerprints. I don't know if you ever travel over United States, Honduras, Panama has this. I know for sure that Costa Rica doesn't have it, but there's a lot of countries. Colombia has it as well. Whenever you travel, they're asking for your fingerprints. Well, the reason they're doing it is because they want to know for sure that you're just getting in and you're getting out, but you're not getting out 2 times in a row, right? So that's a digital trail. It's illegal in the sense that it's the government that is doing it, so it's legal, but it might not be the same identity that has your ID card, for example. It's just another representation. Each of them have 2 representations of your ID. In this context, there's 7.6 billion people in the world when I got these numbers. So we might be a little bit more, but it might be more. Okay, so I'm gonna make a little pause here, and I want to see. I see there's some questions, so I'm gonna address them. Well, first we got some greetings from Diana. So greetings, Diana, and we got here. Is it legal for companies, aside from governmental entities, to store fingerprint information at all? And this is asked by Marco Salazar. Marco, yes, it is legal. It is legal, but here comes some of this is part of the cost thing that I was talking about. For you to have the identity of a person, first you have to have his consent. So whenever you're doing some transaction, for example, in a bank, the bank is gonna make you sign up a form and the bank is in some place of that form is going to say, we are required to collect part of your fingerprints or your facial or your face or your iris, some form of that. So it is legal, but you have to have the consent from the person that you're collecting it from. So if that person says, you know what, I don't want you to have my records, they're allowed to do it, but you are allowed to not provide the service if you want to, right? So whenever we offer this to clients, I had an experience with some clients that it was private, it's a private bank, and they were starting collecting the fingerprints and the identity of the people. And some of their customers said, you know what, I don't want this. And they were just saying, okay, but don't worry about it, because the reason we're doing this is because we want to make this more safe to you. And they started explaining why are we collecting for the fingerprints, and what was the benefits for the customer for us now to have that fingerprints, right? And everything went smoothly, everything was starting doing it. And this was actually, people of old age, people around 70s and 80s, and they benefited a lot from this. So yeah, you need to ask for consent. There's no legal process that you need to do with your current government. Government is not involved in this part, but you are required by the FBI or some other entity that if you want to use this identity of this person in worldwide, you need to fulfill some requirements. This is what the NIST standards are for, and we can talk about this for 3 hours, 4 hours, don't worry about this, but yes, you can do it. And we have an anonymous question here. It says, what do you think is the future of digital identification? What is the next step? Well, actually, we are already in the next step of digital identification, which is we're not only verifying that you are the person you are saying you are, but we're also verifying that you are alive. And this is another question. How can we verify that one person not only is the person he says he is, but is alive? That's the next step of digital identification. I know for certain that Jamaica is implementing one of these things because I am actually the architect who designed it. So don't hold that against me, but yeah, they're going to do that eventually. So that's the next step. Not only verifying that you are who you say you are, but that you are alive. That is the next part. Okay, so let's move on because there's a lot of content that we have here. I got some words that I want to say because I'm going to use them a lot. So first of all, I'm going to talk about identity proofing. Identity proofing is the process of establishing that a subject is who is they claim to be. So because I don't want to keep saying this word again and again and again, I'm going to start using proofing, right? I'm not going to say identity proofing. I'm just going to say proofing or verifying, whatever. But identity proofing is the process, is the process of establishing that a subject is who they claim to be. This proofing, you can use it in whatever context you want to. For example, I'm just going to give you one, which is digital authentication. Digital authentication is the process of determining the validity of one or more authenticators used to claim a digital identity. So I am proofing in the authentication, I am proofing your identity, but I'm proofing your identity in the context of you using this in a digital way. For example, if you want to log into your computer, if you notice, most of computers today, Windows 11 has this feature that you just open your laptop and the laptop starts scanning your face without you actually asking, and he's gonna say, oh yeah, that's Annie. So I'm just gonna log him in. That's one way to do it. We're proofing your identity, and with that proof, we are authenticating your session and we are letting you in. So this opens a lot of ways to do this. You can use this in banking, for example, if you want to give the customer the possibility of not logging in with their identity, with their password or token. You can provide him the opportunity to log in with their fingerprint, which is super easy. It's going to make the life easier for a lot of people that, you know, have problems remembering the passwords. And actually, you can use this as a reinforcement of a password. For example, you have you might have two-factor authentication, which is you ask for a password first, and you say, okay, that's your password, but not yet, you're not logged in yet. Give me your fingerprint. And then you place your fingerprint, and then you log in. This is the most safe way that you can, you know, I don't know, create sessions with your users. This is the safest way that you can guarantee that the session is actually of the person that you created it for. And most banks actually use this. My experience with this is that we have 2 banks working with this two-factor authentication. And there's already companies who do this. For example, Entrust Data Card. I don't know, guys, if you're in the world of banks, if you know about Entrust Data Card, but they actually do this. They have a lot of services for every bank to guarantee the uniqueness and the session of their users by asking for password, for a token, and for the fingerprints, and for the facial recognition. They got everything. So we can integrate this identity proofing and identity identification into a lot of processes, and logging in is one of them. As you can say, I already said AFIS, but I'm going to put a slash there. Remember that AFIS is Automated Fingerprint Identification System, which this is a big system that is going to be pushed in the back of your IT, of your infrastructure. Is going to be placed all the way in the back. Very safe, because, you know, I mean, this is a collection of all the fingerprints of your clients, right? We got to have this safe. But part of the evolution that the AFIS have been having, in 2006, the first ABIS appeared. What is an ABIS? And I'm going to start using ABIS a bit more because this is what most of the companies are selling. ABIS is Automated Biometric Identification System. Biometric means that we're not only identifying you by your fingerprints, we're also doing it by your face. We're also doing it by your voice. We're also doing it by your fingerprint, by your signature, sorry. And we're doing it by your iris, which is very interesting, right? And another word that I'm going to say a lot is going to be template. Now, what is template? Template is actually what we compare. It is interesting that we don't compare each fingerprint with the other one. We don't do that. I don't compare your fingerprint with another fingerprint. What I do is I compare the template that I extracted from your fingerprint with the template of another fingerprint. This helps a lot in terms of processing, memory, because this is very costly, guys. And imagine doing this with 10,000 people, comparing one fingerprint with 10,000 fingerprints. That's a lot. So in order to save some time, we created some stuff that's called template. Template, it goes with face, it goes with irises, it goes with fingerprints, with a lot of stuff. We're going to use a lot of that word, and it says that template is the extracted minutia of a biometric to form a graphed template for storage or comparison. We're going to see an example. Don't worry about this. We're going to see an example in a short while about a template, but just for you to know, whenever I say template, I'm talking about the extracted uniqueness of a biometric, okay? Remember, guys, if you want to make some questions because you're kind of like not understanding, I know what I talk, I know I talk fast. So if you want to say, wait, calm down. Can you explain this to me a little bit more? Please just go ahead and say it, okay? Now, there's 2 types of biometrics. I know that some of you guys might wonder, why are you calling signature biometric, right? It's weird because that's not, that's not bio, right? It's not something biological. Why are you calling signature biological? Well, there's two types of biometrics. We got physical biometrics, which is something that we can extract from the physical features of a person. Those features can be, for example, the human body, fingerprints. It could be your face, which is unique. Remember, even if you are you have an identical twin, this is interesting. Even if you have an identical twin, you're never going to match with your twin if you extract the template from your face. Now, that's awesome, right, guys? Like, you're very close to be alike, but you're never going to be alike. This is awesome. For fingerprints, it's the same thing. If you have an identical twin, your fingerprints are different from your identical twin's fingerprints. So this is very good for banks, for example, because they want to know, really, they want to know that we're giving back the money to the brother, to the holder of the account, and not to the brother, right? So this is very important. And the iris, as you can say, as you can tell, in the iris, you have a pattern in your eyes, in the iris of your eyes, and that pattern is unique, and is more unique than your fingerprints. So we can scan the iris by taking a picture, and we can extract a template from that picture, and we can use it to compare. I know for sure that France has this type of biometric inserted in their some of their governmental systems. Jamaica was going to implement it, by they just said that it was too complicated, and Senegal uses it. There's a lot of European countries that uses it, and the FBI uses it as well. And we have, quick note, something that is going to be related to the question that we had before: what's the future of biometrics? Do you know, guys, that you have fingerprints in the inner of your ears? And that fingerprint that is here in all the inners of your ears is more unique than your iris. So, I mean, that's something interesting for me. And that's going to be the future. I just don't know how would you go about in scanning people's earlobes. It's going to be kind of weird, but that's the next step. We also have behavioral biometrics. Now, behavioral biometrics are patterns or characteristics that might show up on a person's behavior, right? On a person's way of do things. Signature is one of them. I don't know if you guys have signed something in your bank and then you send it over and the teller at the bank says, you know what? The fingerprint didn't look alike. Can you do it again? And send it over and you do it again. Well, it's because they have a system for that. We can actually compare a signature digitally with another signature. And we can tell you, you know what? That signature, it's kind of alike. It's kind of like 98% alike, but it's not the same thing. And you can tell, and the bank can establish that line where you can say, I want them to be 90% alike. If it's below 90%, let's say that it's not the same thing, okay? So that's one thing. I don't know, guys, if you saw the movie, the latest movie of Mission Impossible. Mission Impossible actually has a lot of biometrics and patterns and things like this that they implemented. But one of them, if you guys remember, is the scene of a guy that is walking, right? And the way that that guy walks is the way that they kind of like identify that that's the person that they want to, right? And actually, they have the irises in Mission Impossible that they scan the irises and they say, oh yeah, it's the same guy. Well, that's what we're talking about. And the stride, the gait that's what I'm talking about. The way you walk, guys, I know that you're not gonna believe me, but it's unique. The way that you walk in a room in a straight manner is unique and can be used to identify if you're the person you are. Keystroke is the same thing, the way you write, not the way you sign, but the way you write is another way that we can compare that you're a unique person. And another thing is the smartphone patterns. There's an N missing there, so I'm sorry about that. But this smartphone patterns, there's another way for you to compare if somebody is who he is. Now, before I can go ahead with this one, I see that there's some question. I want to address those questions the quickest way that I can, because I don't want to lose, the flow. Okay, so Israel Biasis is asking, the tech companies used to identify the user's identity by 3 ways. What you are, exactly. This is part of the things, guys, that I was telling you, that I'm not going to go too deep into this, because there's a lot of content that we can go here. Is the way you are, which is fingerprints, iris, and face, what you have, which is your phone or your email account, and what you know, which is your passwords, right? Yeah, that's basically 3 ways that you can use identity of a person. And in the context of the aphysis, we only have those 2, the physical and the behavioral. But yes, there's another ways to identify user's identity, but this is more kind of like authentication. This is kind of more like authentication realm. This is digital identity. So this kind of, let's like a very thin wall between those 2, although they can be used to do the same thing. They might not be the same thing. And I'm gonna explain why in a while, okay? Okay, thanks, Israel. Okay, so let's continue over. Let's get to this section, which is, and this is for, right? This is the question that you guys asking. Okay, there's a lot of words, there's a lot of history, there's a lot of things, exploiting around. There's a lot of terms, but you might wonder, okay, but why do I need this, right? What this is for? Well, the aphysis is more like a biometric solution to whatever needs you might have. I mean, this depends entirely on how you want to implement it, how you want to invest into this, and how serious is the necessity that you have for identifying a person. Basically, it comes down to that. I mean, if you're a restaurant and you have, I don't know, you are applying discounts to people, and you want to say, the way that I want to apply this discount is that I'm going to enroll the fingerprint of the person, and every time that he comes and wants the discount, I want him to place the fingerprint. I mean, go ahead. If you want to invest into that, I mean, there's more power to you, right? It's just that it's very expensive. Most of the times this is very expensive, and only businesses that actually care too much to invest that amount of money are the ones who will end up doing it, okay? So, but basically it's just that, it's a biometric solution consisting of a computer database of fingerprint records, and let's add iris, voice, signature, all those records, which is able to search and compare them to identify known or unknown fingerprints. Modern aphyses are able to search over 1 billion fingerprint records in a single second. The current algorithms are almost 100% accurate. This is important, guys. Almost 100% accurate. Remember what I said at first. We are never going to be 100% sure that Danny's fingerprints are the same fingerprints that Danny collected when he started in this system. We're never going to be 100% sure, because you handle a lot of stuff. You can burn your hands, you can cut yourself, getting old actually changes the features of your fingerprints. So we're never going to be 100% sure, but we're getting close to it. And the fact that we can do over 1 billion fingerprints in a second, it's something very important, guys, because this is different, for example, from when, okay, Israel mentioned that we may use this for authentication, right? He says, okay, what you have or what you are, which is your fingerprints. But this one is different. This one is me placing my fingerprints without saying who I am, and you are gonna say who I am. So you're gonna compare my 5 fingerprints, and you're gonna compare them against the 10 billion records that you have. And in 1 second, you're gonna tell that guy is named Danny Aguilera, and he's been here since 10 years ago, and we have all his records, and we have all his information. Okay. So that's a big flex right there, right? Comparing 10 billion or billion fingerprints over a second of somebody that you don't know. So there's a difference. I want to quickly go over this because I don't want to go over the specifics because this section actually is covered on the algorithm that we're going to see eventually. And so I just want to make you guys paint a picture. I want you guys to know what we're talking about whenever I talk about a template. So as you can see here in this section, I'm going to use here, I'm going to start painting here. As you can see here, this is the biometric that we can use to extract the template from. This biometric could be your eye. This biometric could be your signature, for example, everything. We can get a picture and we can start identifying minutia. That word, minutia, we'll use it a lot. Your irises have a lot of minutia. Your face has minutia. Your fingerprints, everything has minutia. Minutia are just little details that we can use to then create a template. Those little details, for example, as you can see, guys, here, there's a little like bifurcation here, right? You can see that there's a line crossing here, and there's a bifurcation. It's like a river that is going to waste. Well, this section is a minutia, right? So the collection of those minutiae and the relation between them, and this is very important, is the relation between them that we can create a graph. And that graph, this minutia map between those, is the template. And this one is the one that we actually use to compare fingerprints to each other. This is why it's fast. This is not generated by machine learning. This is not anything like that. This was done by hand. This was done originally by mathematics to make this work. This is graphing, comparing, and this is an algorithm. And the only way this gets better is because there are actually mathematicians behind it making it better. This is not machine learning. I mean, you can achieve some of this by machine learning, but it's never going to be as accurate as these algorithms are at this moment. So yes, guys, this is what we create. This is what we compare. And this converted into a stream of bytes is what we can store on the stream. And then we can have that on a database, right? The database that you can have this, I mean, it depends on you how optimized you want your AFIS, but you can do this on I don't know, you can have a Postgres database and have bytes there. You just store it there, perfectly fine. There are some ways that we can do this better. And we're going to talk about those ways a little bit more ahead, okay? So for example, what are the most common biometrics that we can use in civil applications? Remember this word, guys, civil applications, okay? For ABISes, right now, the most famous that we can have right now and the most reliable, because the other ones are kind of like, they're good, but not as good, are fingerprints, face, iris, and voice. Guys, as well, your voice is different, and we can use it to compare who is the guy that is in front of us, okay? So these 4 are the most common, but we can have fake signature, we can have, actually you have fingerprints in your palms as well. This section over here, all this section over here has fingerprints. So we can have a lot of those. but the most famous are the 5 fingerprints, which we call 442. And if you guys been traveling a lot and you go to the United States and they ask you for your fingerprints, they're gonna ask you for your 442. Your 442 is 4 on the left, on the right, 4 on the left, 2 thumbs. And face is the other one. There's a lot of algorithms created by machine learning that extract the template of a person and then use it to compare. But the ones that are being done by mathematicians are much more accurate. So those are used for civil applications. And iris is another one, same thing for the fingerprint. We extract the template, and the voice as well, we have a template. I don't want to get into this because this is very specific, but this, guys, is the difference between how expensive an AFIS can be. This is basically how you can handle the money, right? If you have a casual application of your AFIS, it means that you could be less than 92% sure that you're saying that that person is who he is. Let's say a bank is a casual application, in the sense that banks, whenever you just like, I don't know, just like you want to use as a login for your account on the web app, right? That's one. But computers actually use these casual applications of identification. The one that I mentioned, if you log in into Windows 11 with your face, is a casual application of it. They are not so forced to be more than 92% sure that that's the person they have in front. So you can have that for cell phone unlocking, physical door unlocking. For example, if you have your office and your work, you want to open the door by just scanning the person, the face, and comparing it with the database. I mean, you can be 92% sure if that's the guy, right? And you open the door. So there's a lot of ways that you can do this. What's the key criteria that we can use that to say, okay, it can be casual? Well, if it doesn't present a risk, go ahead and use it in a casual way, right? If this doesn't present a risk, why bother in having an AFIS, very expensive, if it's just gonna be, opening for a door, right? If it doesn't present a risk, go ahead and do it. Now, if it is presenting a risk, for example, if we're talking about money, if we're talking about digital signature, for example, if we're talking about the guarantee that the person that is digitally signing a PDF, we want to know for sure that that's a person, then you need a civil application of that AFIS. It's going to cost a little bit more, but you need to be by NIST standards, you need to be more than 92% sure. You got to be 92% or more sure that that person is who he is, right? The proofing has to be 92% or more. This goes with government issued identifications. For example, the national ID card for Jamaica is going to have a civil application AFIS. The ones that you use to border control, Panama use it, United States use it. Whenever you go to the airport, you're going to request for your fingerprints. Well, they have an AFIS in the background, and it's 92% or more sure that you are the person you're claiming to be. Passports, actually, all the digital passports that we have right now have your fingerprints, and they can be 92% sure or more that you are the person who is holding the passport. So the counterfeit of passports has been declining a lot since AFISs are being used to emit those. And we know bank transactions can do this as well. The bank that we tell you that we have here in Honduras actually uses fingerprints to verify their customers. And so the customers are more safe right now. Like, they're not going to have their money being stolen away just because somebody figured out their passwords. No, they need their fingerprints. So that's one. And digital signature, as I mentioned before, we can discuss about digital signature a lot in some other ways because this is big thing, right? This is a PKI, this is a public key infrastructure that you can have to place in order to back up those fingerprints. So those signatures from the PKI, you need fingerprints, and then you can sign a certification and that the person is who he is, and he can use that to sign PDFs. So this is like a very quick resume about how digital signature works, but that's how it is. Now, there's another thing quickly, because I'm not going to touch this one too much, criminal applications. Criminal applications, according to the FBI, they got to be 96% or more sure that you're going to make an identification of a person. Why? The reason is because if you're 96% sure or less, and you get into jail because you make a match with one person, dude, that's crazy. If you're getting into prison because you made a match against one criminal and it was 95%, it's like, and then you figured out that no, is that you were just a little bit alike, that's a big thing. You might lose your life for it, right? So for criminal applications, the FBI and the NIST department said that you need to be 96% or more sure that you are going to say that person is or is not who he claims to be, right? This is used for prisons, criminal forensic investigation departments, crime prevention units. We had a big system deployed in El Salvador last year. If you guys are aware of what is happening in El Salvador, there's a lot of crime, and there's the police department is fighting a lot. So we deployed a mobile application on a cell phone that is scanning the fingerprints of people. And if you match one crime scene with your fingerprint, you get taken to prison right away. So imagine that by chance you hit with a crime scene 95% and you get to go to prison and you were not the guy. Yeah, that's a big no-no. So you want to be very sure about this. 96% or more, what we do in our crimes. Okay, that's a big talk. And actually, I just want to make sure, guys, that I haven't been taking a lot out of time. I promised that I wanted to. Oh, guys, I'm gonna really quick go over infrastructure because I was talking too much and nobody was saying anything. So I'm gonna quickly overview architecture and infrastructure. This is more like implementing. This is something that software architects are gonna like, in a sense, because they want to know, okay, how can I go about and implement this kind of stuff? Real simple, guys. Your business solution, which is sitting over here, I'm gonna use that pen. Your business is sitting here. You have an app for your bank. You have a system for the bank tellers that are attending the clients. You have a web page for the customer that completely verifies his transactions or wants to send over some money. This is your bank infrastructure, right? This is your bank IT. Inside of your bank IT, there's another safe place where we can store all those fingerprints. And we have all the systems that verify all those fingerprints that we're collecting. So this, as you can tell, it's gotta be very safe, guys. We're talking about the fingerprints of people, about their digital representation. We got to have this safe. So in terms of architecture, you have your unique systems here of your client. You gotta tell your client, you gotta create another safe network, gotta put a firewall here, and we're gonna have that system placed on another place, right? And you almost all the time want to have this duplicated, right? And have a load balancer here. Like I'm telling you, I'm not gonna go ahead and say specifics. And your clients can just access this. You never allow your clients to access directly any interaction with the ABs. That's a big no-no. Don't do that. This is a no, okay? I'm gonna clear this. Okay, great. So what's the basic process for this? Again, real quick, you're gonna have a PC that has a real system that you guys can implement. And you're gonna collect all the fingerprints. We're gonna use scanners for the fingerprints. There's a lot of SDKs that we can use here to integrate, and you can do most of the times. This enrollment applications are for Windows. Those are Windows apps. Those are made on C# or Java, whichever, but those are Windows-based applications. The reason is that it is very unsafe to be scanning fingerprints and sending them over a network to a web page. Very, very, very unsafe. And you can have mobile. So to make this interesting, guys, I want to show you one application that I made. It's a bit old, so bear with me because I made it a long time ago. And with this application that I have here, we can enroll your fingerprints. So as you can see, I turn on the camera and I'm gonna place my fingerprint here. As you can see, I mean, there's a lot of light there, but as you can tell, there was a little circle around my fingerprints and the software recognized that there was a fingerprint there, and he's took a picture of them, extracted them, and now we have a template on my phone, okay? So this is a really good, faster way to implement software enrollment. This section, we are calling it enrollment. And the thing that I was talking to you about, that you never have your office interacting directly with clients or with things that are outside our safe network. If you have that situation, you almost all the time create a broker. That's what we call a broker. The broker is going to take that enrollment. It's going to take the name. It's going to take the ID. It's going to take the, whatever, everything that comprises the enrollment that you want to, direction, address, phone number, whatever. And he's going to send that enrollment to the ABs. So they don't talk directly to the ABs. You never have an enrollment application talking to an ABs. You always have an enrollment, a broker. So that's one thing, okay? I know I'm going quick over this, guys. If you have a question, don't worry about it. Just ask away. I just don't want to lose time because I want to go to the code. I want to show you some code. I'm not going to expand over this thing. I'm just going to talk about them. Inside an AFIS, inside of the architecture of an AFIS, the AFIS is not just one program. The AFIS is a solution. This got created when in the 70s, where I think that it was software as a service that it was most famous at that moment. So software as a service is like comprising a lot of little softwares, and then you got something there serving it to somebody else, right? So there's a matcher. There's one of the solutions that we got there. Got a matcher, we got an extractor. The matcher is just giving you templates. He's gonna compare each other, and he's gonna determine whether it is the same person or not. That's the only job he has. He's not extracting the template. He's not getting the template from the database. He's not, he's not comparing one and another. He's just grabbing two templates and saying that those two templates are alike or not. That's the only job he has. The extractor, on the other way, is the one that gets the image. It might be a PNG. It's going to be a JPEG. Could be RAW. It could be WSQ. I know, guys, you're going to ask, what is WSQ? It's just another format. I'm not going to go into it. But given those formats, he's going to extract the template from it, and he's going to give it to whoever needs it, right? He doesn't know why he's extracting it. He's just extracting it, right? For those architects that might be on the call, this is called separation of concerns in a sense, because we want to separate this very, 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 very costly processes. And so we can escalate eventually. For example, if I know that I'm going to be extracting a lot, I can have a lot of extractors. If I know that I'm going to be matching a lot, I can have a lot of matchers. And that's how we escalate. And we also have some distributed cache repository, and we have a physical repository. Why do we have both? It's because it's very costly for me to, every time somebody calls me to identify a person, go get it from a physical repository. I'm calling it physical repository. SQL, Postgres, even Mongo, all those who write data into the hard drive are called physical repositories in this sense, and it is very costly, and we don't want to do that a lot. So that's why we have a distributed cache repository. Why distributed? Is because I can have, for example, 4 matchers comparing against 4 distributed sections of fingerprints, but only one database. And I'm going to divide this database into 4 segments and gonna give each one 1. So I have a 4th of the fingerprints here, a 4th here, a 4th here, a 4th here. Whenever I want to verify all 1 fingerprint against all, I go start, start, start. And the first one that says I got it, I can kill all these processes. Okay, real quick. There's a big theory about this, and there's a lot of ways that we can actually improve this way of working, but I'm not gonna get into it, guys, because it's gonna take a lot of time, and we really wanna see code, right? This is why I wanted to have this, actually, spoilers alert, if this session goes well, and if this session is liked by you guys, we can have a lot of sessions about digital identity eventually, and we can go really deep down into each of the aspects that we were talking. So just leave your like button there, and if we got a lot of likes, we're gonna have a lot of more sessions like this one. There's a lot of processes that we can have in an AFIS. We can have an enrollment, which is we extract the templates from your fingerprints, and we run a 1 to n. I'm gonna talk about that eventually. If there is no match, we can add that new record to the AFIS, but if there's a match, we mark it as a duplicated. And we say, you want to enroll, but we already have you on our system. Okay, real quick. What is a 1 to n? Whenever we say search or 1 to n is what we call, we're gonna use this section here. We're gonna compare 1 fingerprint against n amount of fingerprints, where n is the summary of all the fingerprints that I have in my database. Basically, that's what it is, guys. Basically is I'm gonna compare 1 fingerprint against all the fingerprints that I have on my system. Now you can say, well, this is gonna take you a lot. It's gonna be very costly for you. You're going crazy. It's gonna take you 1 billion years to do that. But remember what we talk about with the matcher and the distributed cache repository. We can divide the database into different sections. For example, 1/4. We can divide into quarters, into 16ths, 32 sections, whatever, right? You can have that same amount of matchers, and you can do that pretty quick. So that's what a 1 to n is kind of like a search. I'm giving you just fingerprints, and you look against all the fingerprints that you have in the system, and you tell me who that guy is. So for example, I give you my fingerprints, you run it against the AFIS, and you tell that's Zenny. I get Sebastian fingerprints, I send it to the system, that's Sebastian. I have Israel's fingerprints, I run it to the system, and he says, I don't have him. So I can go ahead and enroll him, right? So that's the idea of the 1 to n. Also, we have a 1 to 1. A 1 to 1, I know, you guessed it, is 1 fingerprint against a set of fingerprints. So say I grab the fingerprints of Danny, and I compare them to the fingerprints of Marcos Salazar. And I compare all the fingerprints here against this, and you tell me, hey, they're not the same. Danny was trying to counterfeit Marco's fingerprints. So that's not him. And well, we got an alert here, right? Or we can compare one-to-one the fingerprints of Danny against the fingerprints of Danny, and you can tell me, yes, they're alike, he's the same person. This is not costly, this is very fast. Actually, it's the one that you want to do more. So whenever process you get asked your name first and then your fingerprints, they're doing a one-to-one. If you're not being asked your name and then your fingerprints, they're doing a one-to-n. And there's a little bit here, which is a 1-to-x. A 1-to-x is kind of like the 1-to-n. Is I want to compare one set of fingerprints against an x, where x is a portion of all the fingerprints that I have, right? I think this is pretty straightforward. It's a combination of these two, which is I'm giving you one fingerprint, but I'm telling you against who to compare. For example, I'm gonna compare Danny Aguilera's fingerprints against Marcos, against Israel, against Sebastian, against Diana, and you tell me, is Danny one of them? So I can tell you it's not Marco, it's not Israel, it's not Sebastian, and it's not Diana, right? So that's a 1-to-n, a 1-to-x, and that's a specific search. And because I think we're done with theory, we can go to practice, which is what everybody was wanting. I'm gonna rest all income. So architecturally, I'm not gonna go into this, but most of the times, just remember this section right here outside is what is you most guys interact, and the guys who are the specific contractors for the AFIS work this section over here. You don't worry about this thing. You gotta have a degree like I do to work on this. But you guys without a degree can perfectly work on an enrollment, on a 1-to-n or a 1-to-x or a 1-to-1. But distractor, matcher, cache, and storage, this is very specific, and we can train for that later. And we can get to those specific eventually, not now. Okay, so let's go to the fun part, to the code review. I know there's not too much time, and if Sebastian, if you can help me, just warning me when we are 10 minutes before we end the session, because I'm maybe going to wrap up everything.
Sure, I will.
Okay, thanks. So let me give you a good news. You might be wondering, Jesus, this is going to be expensive, and the license to do this is going to be expensive, and I don't have the money. Well, I have some good news. There is an open source project where you guys can actually download the algorithm, which is open source, and implement it yourself. You can do it by yourself. You can practice. You can understand all about what I was talking about and a bit more specific. You can go to sourceafis.com. .net, sorry. And this guy, Robert Vazan, which is from, I believe, Czech Republic, has this algorithm. He was working with a Chinese algorithm. And he left and he created his own algorithm, which is very good. And this algorithm, guys, is FBI approved. So if you have a project that has to be FBI approved, because it's on banking or it's on government, you can do this. You can do it with this one, okay? So if you guys can go check it, I'm gonna go in a second to there. And actually, I have a project that we can check. It's in .NET, because I'm a .NET developer, but SourceAFIS has a .NET library and it has a Java library. Actually, the Java library is better than the .NET one, which is a bummer. But you can go, guys, to sourceaphis.net and you can get that code. As you can see, you got Java and you got .NET. It's got really good benchmarks. It's really good algorithm, but it's just the algorithm. We have to build everything around it. So I'm gonna show you how to build everything around it. I have this project, which is called FP Verify API. It's called FP because it's only fingerprints. We're not gonna go deep into everything. And it's a test project that I have. Actually, this project is the father of a project that I have on production, and it's called Fingerprint Verify API. It's made on .NET 5.0. I know we have 6.0, and we just got released .NET 7.0, but I haven't got the time to get my hands into that, so don't ask about it. It's made on C#. It's just a small API, and I have a little swagger on it to make your life easier. If you want to get that link, I believe, Sebastian, they do have the link of the project, right? And
I do have it. I will share it with everyone.
Okay, and I'll put it on the chat right now. Okay, I'm gonna stop sharing my presentation and gonna start sharing my entire screen. So if you see a text message popping up of my girlfriend, just ignore it, okay? And I'm going to share my entire screen. Here it is. Okay, there's a glossary at the end. There's a lot of words that I didn't use because I didn't want to get into it, because then we're going to take a lot of time. NIST, APHIS, hit, no hit, threshold, false positive, false negative. Got a lot of wording here, guys. I didn't want to get into them, so we're just going to ignore it, okay? So how can I make this hide? Hide. Yeah, here. Okay. So as you can see, the link is sourceaphis.machinezoo.com. I think sourceaphis.net is not available anymore. I believe he lost the privileges of that domain. So you can have sourceaphis.machinezoo.com. Here you can see the algorithm, a bit more of explanation to it, the Java examples and the .NET examples. So if you're a Java developer, go with this one. If you're a .NET developer, go with this one. But the code is almost the same. It's like right now that I'm going to start code, you're going to see that it's exactly the same. And what I'm doing is just building an API in front of this library. That's all I'm doing, okay? And you can see the Java and .NET sections here. You can see the benchmarks. Benchmarks, guys, this is for product owners. So if you are a product owner, if you want to develop a business around this, just huddle me and we can discuss benchmarks of how implementations, we can talk numbers, and we can talk about what is it that you require, okay? And as well, you can go to GitHub/Danny Aguilera R, which is my name, /FP Verify/API. And you can see this project is public. You guys can contribute if you can make a pull request and you want to work with it. If you want to branch it, if you want to fork it, just go ahead and do it. This is a free repository, and I do it to just to tell people about it. Okay, so let's do this. Let's save everything here. I have some examples. I want to tell you about what I did here. I'm going to build this. I have Visual Studio 2022. If you are going to develop in .NET 5 or greater, you're going to need a Visual Studio 2022 or Visual Code, whichever. So I got this project here. This is the this is the project that I did. You go to program, you go here, I'm gonna make this smaller. So you go to program and you can see this is a small API. We got some services here, the builder, we're adding the Swagger. I added a little database. This database is made with Postgres. I have the repository pattern here because we're gonna need it eventually. And yeah, I just got one endpoint mapped, which is called verify. This endpoint verify is gonna ask for a request. What do we have on that request? We have a probe and a candidate. Remember, guys, this is a matcher. The only concern this matcher has is just to verify whether one fingerprint is equal to the other one. So this matcher in its request is asking for a probe, which is the one that I am going to say, this is Danny, and Danny claims to be this candidate. So we got the probe and the candidate. And because this is an API, I'm going to use base64. I'm not going to use bytes, an array of bytes or blob. We can discuss this about later, but the best way to implement this is not with this API, is with the gRPC. If you guys are familiar with gRPC, a gRPC is the modern implementation of remote process calls that we had in the 70s and 80s, and is actually the fastest way to communicate between systems. And .NET is the holder of the fastest gRPC implementation. So quick note to those guys who are saying that Java is better for the backend. Well, gRPC is on .NET and it is faster. So you can do this on gRPC, you can have it on a blob, and it's going to be a much more efficient, okay? If you guys have questions, I can't see the bar right now. So let me go and check. How can I see the bar again? Let's see, how can I see the bar? Can you help me, Sebastian? If we got questions, just let me know because I can't see them right now. Just hide everything.
Actually, we have a question right now.
Okay.
It's from Alexander Olmedo, and it says, what's your opinion on decentralized identities? Example, connecting a crypto wallet to use a site. Is it better for privacy?
I mean, you definitely want to have, you definitely want to be the holder of the entire truth, right? You want to hold everything on your own repository. So distributed is just internally, but just caching it. So you don't actually, for example, I've seen some implementations that the cache distribution, it's on the same server that is where it's physical. It's because you don't want to have this two apart, right? I don't know if this is your concern, but yes, you want to have it distributed, but very closely where you have everything. You wouldn't want to have, for example, have it distributed on 4 different servers. No, you might just want to have it on the same server, but distributed in different sections so you can target the search on them. I hope that was your question. Okay. And okay, so let's see on code. I have this endpoint, which is called verify. And if we go here to the responses, I have this matcher service. This matcher service is this one, and we got this, right? Verify, you get the verify request, which is the probe and the candidate. We're gonna, I know guys, if you recently read the clean code book, you're gonna start saying, why do you have those validations there? Why you don't get that out? And yes, I will eventually. This is just like something that I have forgotten to do, but this shouldn't be here. But we're testing if we got the probe null. If it's null, we're gonna return a response. that I created. Right now, I just defined the response as undefined, match, and no match. Match meaning undefined is something went wrong. Something went wrong, and I can't tell you if he is. And I can prove the identity. Okay. Match, it means it's valid identity. So Danny is who he's claiming to be. It's valid identity. And no match is no, he is not. He's a liar. Right? So we provided some fingerprints and I compare them and I say, ooh, that's not the guy. So whatever you're doing, if it's not too risky, well, don't worry about it. But if it's risky, yeah, go ahead and be worried about it because that's not the guy. So that's the service that we have here. And if you want to check that code, we can go to that, to here, to the matcher service. And this matcher service, we're going to use the this convert, which is coming from system, where we get that base 64. And I'm gonna put some comments here because I want guys to know this. Check for nulls. Check for nulls. Now you notice something, guys. I'm sending a no match here. I guess this is wrong, right? Because I actually didn't compare it. So I'm gonna send an undefined here, and I'm gonna send an undefined here, right? And I said invalid probed image and invalid candidate image. And then I'm gonna have here converting that probe that I already know it's not null and get it from base 64 into a array of bytes. Now that I got my array of bytes, I'm gonna use the library from SourceAphis. SourceAphis has this section which is called fingerprint image, which is going to get that array byte and turn it into an actual image that I can do a lot with it, right? So here I'm gonna turn decode from base 64 to byte array. I use var, but if you want to be a bit more clean with your code, you can do this, which is a byte array. And this is going to return a fingerprint image. And so we are casting to fingerprint image. And we have a lot of things that we can do with this fingerprint image. Look, probe image, and we got a lot of properties here. Well, they're private right now, but let me show you something. And that image, so remember, guys, the picture, then the minutia, and then the template. This is the section that is going to create the template. Create template. So that means that we're going to extract the minutia and we're going to create a graph. That is for the probe. Now we're going to do the same thing for the candidate. Same thing. Quick note, we can get this out from here and send it over to a new process with gRPC. We create an exactly new solution with gRPC that only handles this, getting data, bytes or base 64 and converting them into templates and giving them back to whoever needs it, right? So this section can be created in another solution. So this section can be a new solution, preferably with gRPC. And this section as well can be a new solution. Well, it can be the same from the one before. Same solution from before. Now I got two templates. I got the probe and I got the candidate, and I get to compare them. So SourceSafis has the fingerprint matcher, and that fingerprint matcher is going to be created from the probe. I'm going to use the probe as telling, okay, the probe is the guy that it's Danny, and the candidate is the guy who says is to be Danny. Okay, just going to put that here. Probe is Danny Aguilera. We know this. We know this from our database. And the candidate claims to be Danny. The candidate claims to be Danny. And what I want to know if he is or is not. Okay, so I do the same thing. I create the matcher, create matcher, and I'm going to match the probe with the candidate. And from that, I'm going to get a score. This score is, what would I say, is from SourceSafis. For example, there's a lot of algorithms out there from different enterprises that are they have different type of scores. Like they have 1 to 100, others have 1 to 1,000, others have 1 to 2,000. It depends on whoever created the algorithm. He decides what's the score that he's going to have. Now, your job, and this is the interesting part, is to decide what is going to be that threshold. Now, I should have done this by an image because this is kind of like a little bit hard. So I'm going to use this, right? Sorry for this, guys, but I really need to do this. For example, you got this section here where you say is, for example, this is 1 and this is 1,000. If I go up from, let's say, 500, then it's a match, right? If I go below 500, then it's a no match. And this line here, this 500, is what we call the threshold. This is what we call the threshold. You set this up by knowing your business. You set this up by knowing the severity of what you're going to do on your implementation. For example, there is, and this is the tendency for score. I'm not going to get into this, guys, but this goes like this. This is a little line that starts, like I'm telling you, it never goes 0. It never goes to 0, and it goes like this. So depending on how certain you want to be on the identity of a person, you can raise or make this downer, this threshold, but the more you get it up, the more it's gonna cost you to implement this. This line here tells you how easy it can be. This line here, this section is, another way to put it is easy, hard. The more you wanna get to 1,000, the more hard it's gonna be. The more data you need to collect, the more processes you're gonna have, the most memory you're gonna have. So this threshold here is very important. You define this when you start creating the AFIS for the client. So I don't want to get into this, guys, but this is very important. Right now, I have a threshold of 40, but let's see, let's test, right? Let's have this running because this code is working already. So we're gonna run this. And guys, if you want, I can actually give you a set of examples of fingerprints. I have in my hand, because I've been working with biometrics since like 12 years ago, 10, 11 years ago. I have this set of fingerprints that I can give you Those are examples from real people. And I'm going to compare this set of fingerprints with another ones. What do you say? Yeah, it's the link there, and those are the questions. Okay. Okay, so here, as you can see, I have a lot of fingerprints. I have Postman, and in Postman, I have implemented the Swagger because I had Swagger in my project. You guys can't see it because we are on localhost. Let's go to Swagger index HTML. Look at that. We got our verify API, and we got an endpoint, which is a GET, and it's requesting in their body probe 64, which is a string, and a candidate 64, which is a string, right? I haven't defined all the responses, but I'm not for sure that I'm going to give you a message, a result, and I'm going to give you the score, okay? So let's go and try this one. Let's go to Postman. I have two examples here in Postman. One is going to have a match, and the other one doesn't. And so let's go the one for the match, okay? I have this body here already. I'm gonna place it over here. Don't judge me on how I use Postman. I know there's a way to have all this implemented, but I didn't had this configured. So I'm gonna send this body on that call to my base URL, which I have on my environment. I'm gonna send it, and let's go. As you can tell, guys, I'm just comparing one fingerprint to another one. I just convert it to a byte, convert it to a template, and then compare it to themselves. And it took me 1 second, 1.4 seconds. Look at that, 1.4 seconds. This is a lot, guys. So this is why we need to be very careful when we implement this kind of stuff. And the architect that we're going to assign to this project needs to be sure of what he's doing, because this 10,000 of requirements about verification at the same time, this is going to kill your server. Okay. So it says, like we said, it's going to be a match. It says that the result was 1. If you guys go to our code, you can see that we have an enum that it says that if it's bigger or equal than the threshold, which is 40, we're going to result a match, which is match equals 1. That's why we have a 1 here. And that's why you have a score of 606. Remember, SourceOffice has a score from 1 to 1,000. Okay, so let me put that in the comments here. The score is from SourceOffice. It comes from 0 to 1,000. Like I said, it's never going to be 1,000. Never. Because we're never going to be 100% sure that somebody is who he claims to be. And let's try, for example, okay, guys, what I did here is I just grabbed these images right here and convert them to base 64. And I just put in them on the body. So you guys can do that later. I can provide you a link of Drive with all those fingerprints if you want to, if you really want to test this. And I have a body here that this is going to throw a no match. So let's go check. I'm going to replace this one here on the body. And I'm going to send it. Okay, let's do this. Okay, now you guys can tell something is wrong here, right? I told you that this was going to do a no match, but apparently the system is throwing me a match. I'm comparing 2 different fingerprints that I knew for sure were not the same person, but they were throwing 210 as a score. Remember the graph that I told you about, the little line there? That's what the problem. The threshold that we planted here, it's very small, and it is not enough to determine if whether it is a person or not. I placed 40. This means that I'm getting a false positive. This is what is called a false positive. I send two different fingerprints, but the system is still saying that it's a match. So this is called a false positive, and I need to go and rearrange my code and try to accommodate the fact that 210 is not enough for my threshold. For example, if I have 606 was right, and that was a match, I knew that was the same person, and I had 210 as a match again, but it was a false positive. What do you guys think it could be the most safest way for us to implement this threshold and be certain that we're not going to get a false positive, but also we're not going to get a false negative? What do I mean by a false negative? For example, I can set 700 as the score, as a threshold, right? I'm gonna stop this. I'm gonna build it and I'm gonna run it. And let's see, because the match throws 606, but I raise my threshold to 700. So let's go and see what happens. So what is going to happen is that if I send, for example, the one that we know that is going to be not a match, and it says, okay, its score is 210, it's not a match. So, okay, this is good. This is perfect for us. But if we send the one for that is a match, that we know that is a match for sure, we send it over, it says not a match. Look at this, guys, not a match. This is what we call a false negative. It means that the system is saying that it's not a match when actually, in fact, is a match, okay? So quickly, what I'm going to do is, there's a big theory about what to do, but I'm going to simplify it for you. I'm going to make an average of 606 and 210, and I'm going to start testing this more and more and more with a lot of fingerprints, with a lot of test data, until I reach a threshold that is actually going to be good for me. And it all depends on how much false positives and false negatives I am allowed to receive. And this falls under the 96% for criminals, 92% for civil, and below 92% for casual implementations of this. So because I'm casual about this, I'm going to go half of it. What do you think about that? I'm going to go half of it and going to go 500. 500 is going to be the threshold that is going to determine whether you are the same person or not, okay? So that's the threshold right there. I'm going to stop this. I'm going to build it. I do this. I know I can't do this. I have the live reload, this one, but I don't really like that. I really like to stop it, build it, and run it again. Seems to me that is the best way you can be sure of something. So this one is supposed to have a match. Let's send it. It says score 606, it's a match. So that's a good one. And if we send the other one, which is a false, which is a no match, gonna send it over, 110, it's not a match. So around this, guys, I wanna just quickly go because I know it's 6:45. I've taken a lot of you guys' time and we haven't even covered one-to-end. For example, this verified, guys, let me tell you something. This is the one-to-one. This is the one-to-one process that we were talking about. We even haven't discussed the one-to-N or the one-to-X. So there's a lot of content that we need to do here. Hope that I get time to implement this on this API eventually, so you guys can have it as an example. But if you want to have this, if you really need this, just feel free to text me on Slack, and I can help you guys implement it. Okay, so if you can see on our code, let's go to our code right before our time runs out. You can see I only have the verify. This verify is, like I told you, a one-to-one, but I went ahead and implemented something here. For example, I was implementing my broker. Remember that I'm always going to tie one person to one record. And those records, for example, can have what I told you, 442. For those, remember, you have to store the right index, you have to store the right middle finger, the right middle, and you got to store the right ring. These guys are official name that the FBI gave to their fingers. Right ring, the right small, little, not little. It's little. The pinky is actually called right little, I think. And you got the right thumb. And then you got all those 5 fingerprints graded as well for the what? You guessed right, for the left index, left middle, you get the left ring, you get the left little, and you get the left thumb. If I compare all those fingerprints, every time that somebody send me the 10 of their fingerprints, I always compare right index with right index, right middle with right middle, right ring with right ring, and like so, right? Each one with each one. I'm not going to lose time comparing the right index with the left middle. It's a waste of time because we know it's the right index. So we are going to only compare right index to right index, okay? There is a case where we compare one to each of those, but this is for criminals because when we scan it on the crime scene, you don't know what finger was, right? So because you don't know what finger is, you just compare it with everybody. And if you get a match, oh, that's the finger, is the middle finger. And so we have our fingerprint records for each person, as you can see here. And we have that record against a person. You can have 10,000 records from one person and just use the best ones. There is a score that you can that you have for fingerprints. For example, each fingerprint can have a score from 0 to 5, depending on how good it is. If you have scars or you have your fingerprints burned, you can have a score of 1 or 2. But if you have really good fingerprints, if you haven't washed a single dish in your life, you're gonna have a 5 score in your fingerprints. So it's very important for us to collect really good quality fingerprints because we want to have the best ones for having the best quality to compare. So for this, what I would do, for example, if I go to the matcher service, in the matcher service, we got a verify, which is getting the probe in base64. But for example, my matcher could do the same thing. I could have the verify response, and I can have a verify, but with a different signature, which is a byte array with the probe and a byte array with the candidate, right? And if I create a different service that I told you guys, remember that there's a broker, you can, for example, create a verify, and you can do the same thing, and you can call that one matcher service. You can get a single enrollment, for example. In this single enrollment, you're going to create a 1 to n. So you're gonna get all those records from the database divided in different sections in cache, and then compare the fingerprint with all of them. And if you do that, you can tell, okay, this guy is new and I can add him, right? So you're gonna start recycling your code. For example, for the match your service, I'm gonna start using the verify that only gets the bytes, and start using it for the 1-to-n, for the 1-to-x, for the 1-to-1, for everything, right? This is part of the clean code concepts that we have, and also part of the architectural design that we were going to. Right now, the most famous architectural paradigm that we're going to use for AFISes is microservices. And of course, why don't we, right? We got Docker. On Docker, you can use Docker Swarm to expand all the services that you want to into the amount you want, or you can even use Kubernetes, and you can use Kubernetes and create pods, and those pods can have a lot of matchers and a lot of verifiers and a lot of searchers and a lot of brokers and extractors, right? I know I'm perusing over all these concepts, and probably you are a little bit more curious about this kind of stuff, but this is the time that we got right now, and I really want to leave this last minutes for questions, because I don't want to talk too much anymore. So I don't know, guys, do you got a question? It could be the question on theory or code if you want to. I've actually worked with the Java version as well, so it's not a problem for me. But I don't know, guys, anybody has a question? Remember, this is product owners, this is software architects, this is software developers, and this is project managers as well. I mean, remember this, what we're discussing right now, this is a business, right? This is a solution that might be the next problem solver that you're gonna require in your next project, okay? So I don't know, guys, I can leave the open floor for questions if you want to. Okay, so I either explained too well or nothing got explained too well. I hope it's the first one, okay? But I mean, we got 5 minutes. I just want to let you guys know that I'm here for any question that you got. If you're guys from Detsu, I'm here in your Slack. I'm Danny Aguilera. You can huddle me anytime. I can answer whatever question you got. And let's vote for the next Detsu Lab for this one if you didn't find it too boring. And I can expand a bit more on almost every topic that we were discussing. So I think we're good. Oh yeah, sorry. It's Danny. Let me get that link. It says Danny Aguilera. That's me. And yeah, it actually, Diana, it is very interesting because it seems something that we didn't know, but once you get to know it, it makes so much sense, right? That this is the way most of the companies are working since 50 years ago on how to handle the identity of a person over the internet, over the digital world. So yeah, Sebastian, I think I'm good. I think there's not too much questions there, but I think we're done for the day.
Sure. Excellent, Danny. Let me tell you that for me at least, the whole explanation was perfectly clear. So thank you very much for illustrating us on this overview of digital identification. It has been a really great presentation, and I'm pretty sure that we are all left wanting to continue listening to you, especially on the code part. So I guess we'll have to think about making a second part all about the code, huh?
Yeah.
What do you think?
Yeah, definitely. Actually, COVID, this is a really good comment, Sebastian. COVID opened this business a lot. There's a lot of necessity of identifying people or guaranteeing their identity over the internet, just because we don't want you close to our offices right now, right? We want you in your house. We want you to be safe. So having the ability to confirm that you are who you are without you actually going to our office, it's a game changer.
Absolutely. I bet it did. Well, the COVID changed a lot of things around us.
Yeah.
So
Yeah.
thank you, Danny. And to all of you guys, thank you very much for taking the time to be here with us. And don't miss our next Devs Lab in 2 weeks. For those who join us from Zoom platform, I remind you that when you leave this webinar, you'll be asked to fill out a short survey. We'll really appreciate if you take a couple of seconds for answering. So that's all for today. Thank you very much. Until next Devs Lab. Good night.
Okay. Good night.